Hello, everyone. This is your host, Sanjeev Mohan of the It Depends podcast series. As you can see, I am in a very special place. What you are seeing is the top of the conference center in Amsterdam. I am attending KubeCon Europe 2023, and this is day 2. Behind me are the spires of the Rijksmuseum and Van Gogh Museum. So this is a very special place. In fact, this place is so special that finally the fury of generative AI has been muted by the frenzy of Kubernetes. But the question that still begs amongst many of us data professionals is Kubernetes really the right solution for our data needs? To answer that, I went looking for Gabriele Bartolini. He's going to join us from Enterprise DB. We've been talking about doing this podcast for almost 1 year when we met in Valencia at KubeCon. So, Gabriele, thank you for coming. So nice to have you on this episode.
Thanks for having me, Sanjeev.
You're welcome.
It's a pleasure.
Yeah.
Hi, everyone.
And you're from?
Italy, Prato, Italy.
Prato in Tuscany?
Tuscany, north of Tuscany.
North of Tuscany. Very nice.
Close to Florence. Yeah.
I see.
It's a beautiful city.
Very nice. Yeah. So maybe we should do our next recording in Prato.
Yeah. You're always welcome. Yeah.
That's great. How long have you been involved with Postgres?
So I think it's 99, 2000. Yeah.
I see. So almost about 25 years?
Yeah, almost. Yeah.
I see. And what were you doing at that time? Like what?
I was so I had been fascinated by open source.
I see.
So I was in love with Linux. Then I was studying statistics at the University of Florence, and I fell in love with data warehousing and data mining, all these kind of disciplines. And while doing my kind of research, I wanted to use a database, and I tried first MySQL, and then I decided to go with Postgres. And since then, I've never stopped using Postgres, to the point that it became my business when in 2008 I co-founded with Simon Riggs and Johnny Cholly the Second Quadrant, which was then acquired by EDB in 2020, and now I'm at EDB.
I see.
So
and
that's the whole story.
And you've been a contributor to Postgres.
So I think my main contribution has been Barman. Barman is a popular open source backup and recovery tool for Postgres. And also in terms of community, I'm one of the founders of the European Postgres Association, and I think I'm the one that organized the first Postgres conference in Europe in 2007, and since then, there's Postgres conferences all over the world. So I'm really happy about that.
That is great. So let's pivot to Kubernetes. Yeah. How did you make that shift to Kubernetes? Is Kubernetes the right way to go? What's going on in that space?
I think Kubernetes is the right tool if it works for you. Yeah, you can't jump on Kubernetes like you cannot jump on Postgres without knowing Postgres. Okay, so you need to know Kubernetes, and it requires a mind shift. So you need, I think, to really open the door and look at what's there. So learn Kubernetes. I think that the CNCF provides a lot of certification paths that are useful. I think the CKA is probably the one that provides you with a lot of information if you want to manage databases. And I bumped into Kubernetes basically thanks to a DevOps journey that, with my team I was doing. So always learning new technologies to improve the development process, and also to improve the productivity in our organization. Yeah. I see. And also create a happier environment with people that were, motivated and felt as attached to the organization.
That's great. And the bridge between database management systems and Kubernetes is the operator?
Yeah.
What is the purpose of an operator?
So the operator is basically, it's a pattern that is now become, the best way to extend the Kubernetes controller by essentially simulating in a programmatic and automated way what a human being would be doing. So in the case of Postgres, the operator needs to simulate what a human DBA would be doing in case of, a failure, or in case of even just, the standard life cycle of a database. So what we've done, for example, we have developed an operator is to put all our experience inside this kind of extended brain of Kubernetes that is responsible to manage one or more Postgres clusters. So it's kind of, our 20 plus year experience put into this.
So what you're saying is that the operator is abstracting what Kubernetes you would manually do on a database and in Kubernetes. So is it like infrastructure as a code? I can write a declarative statement that says, go deploy.
Correct. So basically we defined the desired state of our cluster. So for example, in an imperative way, so before, to create a 3-node cluster for Postgres, you needed to create the primary, then clone, create the standby, then clone and create the replica, a series of steps. In a declarative world, you say, I want Postgres 15 with 1 primary and 2 standby, and that's it. And Kubernetes, with the reconciliation loop, it needs to make sure that at any time, there's always such a cluster with 1 primary and 2 standby. So if one goes down, it's recreated and so on. If the primary goes down, it needs to automatically issue a failover and so on. And so the operator has been programmed in Go to respond to this kind of triggers, that
I see. So the operator is written in Go, like Kubernetes itself is written in Go, correct? Because Kubernetes came from please correct me if I'm wrong. Originally, Google came up with Borg, which was C++, and then Kubernetes was written in Golang. And so, so the operator is in Go, but the end user is writing a YAML script. Correct. So they don't need to know.
They don't need to know. It's entirely transparent.
I see.
So they write a definition. And in our case, for example, we follow convention over configuration, which means that even with just a few lines of declaration, for example, you can even just write 5 lines, and that's enough for our operator to create a cluster.
The language that you use.
YAML.
So using YAML, the syntax that you put, is that syntax a standard, or would it be different from one operator to another?
At the moment, every operator has its own. So we have decided our own. It's a specification. So there's a public API. So basically, we define a public API, and that's how we talk and we interact with Kubernetes essentially. So through a YAML file. So we type kubectl apply, and we apply the YAML file, and that's it. You've got the primary is created. Then the operator creates the replica and the other replica, simulating what the human being would have been doing.
And outside. The advantage of Kubernetes is that if for some reason one of the instances goes down, then Kubernetes is self-healing.
That's one of the capabilities of Kubernetes, self-healing. You've got scalability. So for example, you can scale up and scale down.
So you define it in the configuration file?
You change, for example, instances from 2 to 3, and it generates a new replica. Then 3 to 2, it downscales.
I see.
And then, for example, there are other important features that we have defined in our operator, including logging. So the logging is automatically returned in JSON format in standard output, like Kubernetes recommends. And monitoring, we provide a Prometheus exported natively with a set of out-of-the-box metrics, and users can extend them with configuration, writing their own queries to monitor other parts of the system.
So a lot of DevOps operations.
It's yeah, it all comes from DevOps.
I see. So the operator that you have written,
yeah.
First of all, is it open source? Is it proprietary? How?
Yeah. So and here I really, I really thank EDB for that, because they did something, in my opinion, unprecedented. They last year about this time, we were able to open source the operator that had been in production for almost 2 years already. It was a closed source operator, and we open sourced it last year, and EDB donated that to an independent community, the Cloud Native PG community. The open source operator is called Cloud Native PG.
I see.
And it's entirely owned by the Cloud Native PG community. The intention of EDB was to apply for the CNCF sandbox to ultimately, donate the project to the CNCF. So we actually applied last year, and it was, rejected. So we need to reapply, but I think, eventually we'll get
I'm
there.
sure. Yeah.
So
and
it's Apache 2.
I see.
So Apache 2 license.
Okay.
And there's an open governance model that we have adopted. So I think everyone is encouraged to participate. It's the growing community.
I see. So Cloud Native PG.
Yeah.
That is the name of
the open source
Kubernetes operator for Postgres.
Yeah. Initially developed by EDB.
Correct. But so developed by EDB, was in production for 2 years, but now it's open source.
Yeah.
Are there other operators also available?
So there were already other operators. So we were not the first. I remember that in the Postgres community, the first time I saw Kubernetes with Postgres was with Zalando. The Zalando operator has been in production for many, many years. And also there's, I think another important one is Crunchy. Then there's other operators like Stackgrace, I think also the Percona one. So there's a few of them. They all use a failover management tool.
Okay.
Whereas our operator is essentially has that logic built in.
I see.
The operator. So the Kubernetes system has the knowledge of the status of the cluster at any time without asking or delegating another player to manage the failover.
I see. Where is that status stored? Is it like a key value?
etcd,
Sir?
like, in the API server. So
in the API server, I see.
Kubernetes.
Okay. So I believe Cloud Native PG is being used quite a lot here at the conference. I think you.
Yeah, it's interesting to see, that, go through the booths.
Yeah.
There's companies that are, showing database as a service, and they run Postgres, and we discovered that running.
How do you know?
We asked. And they said, "Oh, we're using operator called Cloud Native PG," and we said, "Okay, we have
you wrote
it." So, that's good.
I see.
Yeah,
I think you also mentioned that you saw there were some screens, like some Grafana screens,
Grafana dashboards. So we, my colleagues noticed that, and
I see. That's how they knew. Yeah. Wow, very interesting. $1 million question: when Kubernetes first came out in the market, it was meant for stateless. But then for years we've been hearing about stateful sets, and it's ready, it's almost ready. And I believe it was only in February that Kelsey Hightower finally put his weight behind databases. He said it's okay. And we just came from his session, and he said it was always ready. There was no question that it was not ready, but now he feels it's at a level of maturity. So what are your thoughts?
So I think it's interesting because it's basically confirming, our the opinion that we have developed throughout our journey. Okay, so essentially, if I can interpret his words correctly, he says that provided you know Kubernetes, provided you know Postgres, provided you've got a good operator, you can run Postgres in Kubernetes like you were doing in VMs before, okay? And this message, I think, what came out in February, yeah, and I've already seen, people coming to me saying, "Oh, now, Kelsey says that, we can use databases," and, I said, well, actually, it is because we understood that it was not only feasible, but in my opinion, the best way to run Postgres is in Kubernetes.
I see.
So, and I've been running Postgres for many years. Okay,
what is the overhead, if any? Performance, latency,
Yeah, so basically, when I started this project, the first experiment we did was to fail fast. Okay, so I didn't want to spend time with my team and my organization back then on something that would not have been used by our largest customers in the world. So what we did was start this experiment to run Postgres in Kubernetes on bare metal. So we set up a physical Kubernetes cluster with each node having local disks. And we perform benchmarks on the storage and the database. First, Linux directly, and then Kubernetes. And on the storage, I think that the penalty was less than 1%.
Okay.
Which is pretty much nothing. Okay. And in terms of OLTP transactions, was less than 4%. So that's when we say bingo, we can call
and this is out of the box.
We use OpenEBS at the time. And that's how actually I got to a very important, I think, community that has grown from the day I published that blog article. That was, I think, June 2020. I was reached out by the CEO of Mayadata. We had used OpenEBS to run our benchmarks, and he told me about this data on Kubernetes community. And, if I wanted to be involved in this community to build awareness about running stateful workloads in Kubernetes. And I think that community has grown so much, I think has played a very important role in building confidence about running any kind of stateful workload in Kubernetes. And the beauty is that you've got pretty much all the options from entirely shared architectures to dedicated architecture, where you actually say, I want this node to be fully dedicated to a single Postgres instance, and even have, a SAN attached to that, like we used to do back then,
Okay.
And then have Kubernetes orchestrate, manage failover, and so on. So just with taint and tolerations, we can just configuration, as I said before.
Right.
Infrastructure as code, we can manage all these data centers,
I have a million questions in my head about what happens to the rollout of the DBA. How do you do portability, reliability? But before you go there, you mentioned about something called Data on Kubernetes Community, or DOK.
Yeah.
So there was a sold out show.
I almost
session.
missed it.
You almost missed it, although you are such a key member.
I was waiting for 5-10 minutes to enter this morning. Yeah.
So that is a level of interest that we're seeing,
Yeah.
So viewers, we have a surprise guest to talk about data on Kubernetes community right after we are done talking. So you just have to wait and get all the information on how to join it and how to participate actively. But let's go back to what is going to be the impact of Kubernetes managing databases to the work that DBAs do.
Okay, so I want to say something. Less than about a month ago, I had a workshop, and a DBA came to me and said, I'm going to lose my job. Now, I mean, with this,
generative AI, everybody's going to lose their jobs.
So. Yeah. And I said, no, actually, I think your job, you have an opportunity here because your job will be elevated. Your skills can, be more useful for developers and for the whole organization because you have been removed by all the stuff that could be automated and could be done in an automated fashion and could also prevent you from being called at 3 a.m. At night because the primary goes down.
Yeah.
And so I think the DBA, in my opinion, going back to the DevOps, culture in an organization, what we do is complex. Okay, so I think we need to work in teams and teams with multiple skills, ideally with T-profile people, so the people that are specialized in one area, but can also talk about other areas and meet other T-shaped profiles that are specialized in other areas. For example, you've got a T-shaped DBA that talks to a T-shaped developer that talks to a T-shaped Kubernetes administrator. And, the horizontal part is done by, could be done by pipelines, by GitHub, by, all the technologies you got in the organization and Kubernetes as well. So at least, understand the boundaries and understand also the links between all these profiles so that they can work together in a single team. And the DBA basically can do the more interesting stuff about monitoring, building dashboards, creating indexes, checking the indexes, checking the general health of a database, not, the instances like we were doing before, worrying about keeping up the systems and so on.
I see.
But for example, they need to know how to recover, how to do recovery with an operator like ours. Okay, so there's some unlearning and learning to be done, but I think that it's for the best. And I remember that after I explained this, even the DBA agreed. So and it's all changing, it's all happening now. So that I think we'll see. We'll have a clear idea maybe in the next months, next years, about the change that we are actually, I think, leading.
So basically, it's what the industry, actually AWS invented it. They call it this undifferentiated heavy lifting. The monotonous pieces, those can get automated by Kubernetes, so the DBAs can focus more on even things like data integrity, validation. Is my data correct? The
model. Help
data modeling.
Exactly.
Correct.
So, for example, knowing when to partition, help developers with SQL, this kind of stuff. Correct. SQL is, I think, the most underestimated language we have.
Oh, really?
Yeah, so I think SQL is very rich, and we think that, I think we're only using probably 1% of its potential, So I think that's also, I think that I'm trying to move forward with the Postgres community is to actually restart from scratch what we had done 15 years ago when, we were actually building the Postgres kind of market because Postgres was a community project. To do it again in Kubernetes, so the new generations know what what Postgres is already able to do. Okay, so explain SQL, explain all this kind of stuff to the new generations. I think that's what we have to do.
This is very exciting. So it seems like we are seeing a rebirth. Like you said, 15 years ago, there was a active community on Postgres. Now it's the same, but with Kubernetes added to it. So it brings a new level of richness.
Yeah, I agree. And I think it's the opportunity to start a new S-curve,
I see.
Otherwise, this is usually the maturity.
Kind of. Yeah, it reaches a plateau
and then goes down.
Yeah, and then goes down.
So now I think we have the opportunity to start a new curve.
Oh, wow.
With Postgres in Kubernetes.
Very interesting.
To reach, I think, a completely different audience. Okay, because at the moment I think databases are still not seen as they should be seen in Kubernetes. And that's part of, they need us.
What is the new audience? Where is that audience going to come from?
People that are born in Kubernetes. Okay, so developers that the first thing they do is work directly in Kubernetes.
Okay. So more like people like younger developers who
startups.
Startups. So they're used to cloud native is all they've ever done.
Exactly.
And they write microservices. So they can now incorporate Kubernetes orchestrated databases.
Correct. And you said the right microservice. I think one of the goals of our operator is to actually design the microservice database. So the idea is to make the developer, each application responsible for their own database. Okay. We were used to the kind of monolithic database because, for example, you could save on licenses, you could save on this is all a new paradigm. Okay. You don't have to think about that. So that's when I say you need to unlearn. Okay, you need to.
I do need to unlearn
that. Not you.
No, because I come from, my origins were a monolithic database. I used to work for Oracle decades ago, but that's what I know. So what is the new paradigm?
So basically, every developer has the chance, and this is, I think, the advantage of Kubernetes, is that developers can be almost independent to develop their own applications, and now they can include the database in their pipelines. So to test. For example, test upgrades, test migrations, test that their application work correctly with the database, and so on, directly in the pipeline, and ensure continuous delivery, for example. So there's applications that are being deployed 10 times, 100 times a day, so in an automated way, and we have the possibility to introduce automated gates that also check the database.
I see.
Okay, and I think this is so basically this way enables to deliver new features in a faster way and build value for the organization, shorten the lead time for value generation.
The time to value, is you're making it, you're accelerating the whole development, new features, what businesses have been asking for. So in the past, if a business wanted a change, then it would go through a very long, complicated 3-month-long process of changing the data model, creating a data mart. So now we can respond faster.
Yeah, and and because of Kubernetes, because of the clarity configuration, and if you put all of that in a version control system, you have a clear idea of what combinations and versions of software you have at any time in your infrastructure. So you actually facilitating compliance and change management operations, So
this is a very refreshing view, I have to say, because to me, up till this point, till right now in our discussion, I always thought of Kubernetes as a sort of a back-end automation, to simplify my deployments and HA, DR. But what you're saying is far more important, which is the developer community now has a control. And they can very easily, using what they already know, like scripts and all, they can now have a local database closely sort of coexisting with the application.
They're kind of responsible for that as well. And that's where I think DBAs need to be integrated. Okay, they need to work with the developers, help them write queries, write tests, help them model the database and so on. I think that's one of the tasks that the DBA can now, I think,
so another $1 million question, which comes up all the time and just came up just a few minutes ago when we were talking to Kelsey, is Kubernetes is very complicated. So that's it. It's just too complicated. He had some really interesting points he made. Maybe you can share.
Yeah, he said it's like a human body. The human body is a very complex, but we need we need pretty much every fingers, feet, and so on. So I think it's complex because we are not managing a machine, for example. We are managing an entire
process?
No, the entire infrastructure, and
yeah.
infrastructure stretching across multiple data centers
Mm-hmm.
and so on. So I think we are kind of pushing down the complexity and the risk,
Mm-hmm.
the management risk from applications
Mm-hmm.
down to the infrastructure. So that's why we need skills. We need people that know Kubernetes and know how to set up the infrastructure. So you work, you get a self-managed Kubernetes infrastructure, or yeah, depends if you want to manage that yourself. It's up to you. But I think in that case you need the skills.
Yeah,
and
I think
but that will basically reduce the risk and the cost at the application level, because, for example, if you've got 3 availability zones, 3 data centers, and a stretching cluster, Kubernetes clusters, if one data center goes down, you are protected, because Kubernetes will ensure that workloads are functioning in the other 2. Okay, so whereas before, for example, we had to actually manually intervene at the database level. So in this case, for example, if one goes down and you've got a primary, the operator issues immediately a promotion in a switch over, failover actually on one of the standbys that are in the other availability zone. So you don't even pretty much notice that. Okay. So this is important.
Yeah, and one thing that I really found interesting was what Kelsey was saying was that, yes, human body is very complex, far more complicated than Kubernetes, but an average human doesn't know that. They don't care. They don't think about, how does my brain work, or my kidneys and lungs? They don't even have a clue, but the doctors do. So like this conference is where the surgeons of Kubernetes have come to learn how the infrastructure piece is, the complexity of that. But the operator is simplifying it to a point where the end user, the developer, is not worried about Kubernetes. The developer is just writing the script and then running the kubectl command or whatever it may be, and all that complexity is abstracted away.
Yeah.
Is that
correct?
The right way to put it?
And then, if you've got problems on the Postgres layer, you need the Postgres expert to get there, or on the Kubernetes layer, you need the Kubernetes, like the brain surgeon, like it was referring before, or,
Right. So going back to your open source Postgres operator called Cloud Native PG, that, if I'm not mistaken, is also what's used by enterprise DBs, big animal, DBaaS?
Yeah, that's correct.
How does that work? What is...
So, I mean, that also gives you an idea about the confidence we have about running data in Kubernetes, because EDB has decided that, for our database as a service, we run in Kubernetes. Okay. So essentially, we also have a fork of Cloud Native PG. So Cloud Native PG is the community one, and we've got a small, there's not much difference between the open source operator and EDB fork, which is called EDB Postgres for Kubernetes. But for example, we provide support on OpenShift, Rancher, Tanzu, and so on. And also we provide a long-term support version, because the community has a very fast release cycle, and we support as a community only the last two minor releases. So normally a release is supported for 5 to 6 months.
I see.
But organizations are asking for at least 1 year and a half support.
Okay.
And that's where EDB jumps in. And then we've got some special integrations with some backup tools, enterprise level backup tools, and so on.
So the Cloud Native PG operator that you have, does it need to be compiled or made available to run in Amazon under EKS and in Azure under Azure Kubernetes Service and Google's GKE? How does it work?
So that's another big advantage of Kubernetes, is that it standardizes infrastructure. Okay. So it removes the vendor lock-in of the cloud service provider.
I see.
Level. Okay. So you can now be on EKS, which is the provided Kubernetes service by Amazon, and then decide to go to Azure. Or you can, for example, our operator gives you the ability to have it's called replica clusters. So you have a primary cluster in, for example, Azure, and then you've got a replica for disaster recovery in Azure. So you can have multi-cloud kind of setup.
Oh, wow.
And then maybe every 3 months or 6 months, decide to move primary operations to the other data center.
See,
and so on.
That is huge, because you have the portability of Kubernetes, but you can now also do, maybe there's some data sovereignty laws, data residency.
Exactly.
You could do,
especially in Europe with GDPR.
You could do, so you get this resilience between multi-cloud resilience, because in Europe, I know there a lot of governments are very much focused on cloud concentration risk, that if everything is in AWS and something goes wrong, then how easily can you move to Azure or Google Cloud?
And I think in the database space, we know very well vendor lock-in, and I'm not mentioning anyone. I think, our company is specialized to move away, on Oracle migrations, for example. And for example, another interesting pattern is to move. There are some actually customers that are asking us to move from on-prem a virtualized Oracle into Postgres in Kubernetes directly with our operator. And then the other good thing of the operator is that, even the open source one also supports ARM architecture. So you can use, for example, Graviton in public cloud. And the EDB Postgres for Kubernetes also supports on OpenShift Power and Z systems. Okay, so we can, and also the EDB Postgres for Kubernetes enables EDB Postgres Advanced, which is a server that has a compatibility layer with Oracle. And we are also working on the multi-master product called Postgres Distributed. So you'll hear from us soon about PGD in Kubernetes.
I see. So the one question I have is, although using Kubernetes, you can have primary in one cloud and replica in another, how practical do you have production customers who are doing that? I'm just wondering, what is the latency? Is it synchronous? Is it asynchronous? What's a RPO if something went down?
Okay, so this is so there are two ways, in Kubernetes to replicate this state. One is through storage and one is through the application. We have developed basically the Postgres replication system. So with my previous company and EDB, that now, they're the same thing, but at the time it was written by my other company. We have pretty much written most of these layer in Postgres. So we know very well the stream replication which is very powerful because it can be controlled also at transaction level. And so we have implemented that into the operator. And one of the cool things of Postgres is that you can just rely on WAL file shipping if you want to have a replica in another region. So you actually don't need a connection between these two. You just have, the WAL file, so the transaction file. So the WAL file is write-ahead log is the transaction log, which is one of the most important things in a Postgres database. It's archived. We define in the operator that every 5 minutes at the top, it is archived. It's sent by an object to an object store. And then the other region can read from that object store and replicate. And this is continuous. So this is in continuous backup, continuous archiving. The other one is in continuous recovery.
I see.
Okay, so without this, without any connection, you already have almost maximum RPO 5 minutes out of the box, which, it could be okay. In some cases, it's not okay. In that case, you can create a network connection and have streaming replication. You have a dual channel and reduce RPO in some cases to almost zero.
I see.
Okay. Then if you want, you can, but that depends on the latency, request to have zero RPO, so synchronous replication for some transactions, but really, across regions, almost zero is acceptable in my experience.
Right.
So,
and you have customers who have requested this, like almost zero RPO?
Yeah. We have customers that have these in production as well. Customers that are fine with just the object store replication.
I see.
Okay.
What is next? What is your roadmap items for the next release of?
So we are planning to release next week version 120 of Cloud Native PG, which will include the declarative role management. So basically, in the YAML file, we can define the Postgres roles that we want, and the operator will ensure that at any time those roles are there. And the other one is declarative hibernation. So with declarative hibernation, you can say this cluster is hibernated, so the pods are shut down and only the PVCs are there. This is thanks to the fact that we don't use stateful sets, but we directly manage PVCs through the operator.
Can you explain what a PVC is?
So stateful sets are basically the most common way to manage persistency, okay, in Kubernetes. And I think almost all the other operators use that. We decided to bypass that and directly control the persistent volumes.
I see.
Okay. Yeah. So this way we're able to perform, for example, volume expansion. So if the CSI driver supports it, we can expand the volumes. Then we can perform control rolling upgrades. We can fence nodes. So for example, for crash, in some cases, we might require to investigate a data dir, so data directory. So we might want Postgres to be down, but enable us to enter the pod and check if there's some data that is corrupted or something like that. Because it could be that the storage doesn't honor the fsync, for example. Okay, so all these features are possible because we directly manage the PVC, and this is, we are probably one of the few operators out there that.
So no stateful sets. Stateful sets anyway was the very first attempt to provide persistence, right? So I thought we had moved away from that, but you saying other operators still use it?
Yeah. And I think Kubernetes in general wants to improve stateful sets, and we are trying to work with SIG storage. I think we've already discussed with SIG storage.
What's SIG storage?
SIG storage, special interest group about storage in the CNCF.
Right.
About why we made this decision, to the point that we wrote a section in the DOK, the documentation that explains why we went down this path.
I see.
So the idea was to collect, reasons why some operators didn't choose stateful sets, and so we did.
So I'm sure some of the viewers at this point are wondering that I thought all this time we've been told to move to a database as a PaaS or even SaaS, serverless. And now you certainly dialed back the thing and you're like, no, this is how you manage it. So what are you seeing? Like your customers, although since you're the Kubernetes person, I'm sure you see a lot of self-managed databases, but where is the trend these days?
No, I think it's, what works for customers, to be honest.
It depends.
Yeah, what fits the, each organization. Every organization is made of people, and, the skills that these people have, and, what they want to do. Some, for example, if you don't have Postgres skills and you don't intend to build Postgres skills, it makes sense to go for a DBaaS, for example. But if you have strong Kubernetes skills, and you've got developers and you've got also DBAs, and you want to have full control over data, because this is also another important thing with Kubernetes and our operator, is that you have access to the data, to the directory where data files are, you know. So
you
can
control.
encrypt.
You can.
So you have full control on
right.
that. Okay. So with the operator, for example, with the open source operator, you can encrypt at the storage level. Whereas with EDB Postgres for Kubernetes, we also have possibility to use transparent data encryption in DBaaS 15, which came out a couple of months ago.
So TDE came out.
Transparent data encryption
came out only in Postgres 15.
15. Oh, wow. EPAS, EDB Postgres Advanced.
Right.
And EDB Postgres Extended.
Because I know the TDE concept's been in SQL Server for a very, very long time. So I didn't know it just came out. So this is interesting to see how some organizations may be already familiar with Kubernetes, because we are talking about databases, but they may use Kubernetes for Kafka clusters, even for other types of databases, like MongoDB has a operator, correct? Cassandra, DataStax, they have an operator. So Kubernetes may so if an organization has deep Kubernetes skills and they have Postgres configuration, tuning, all of that, then self-managing a database gives them controls that they may not have in DBaaS, like, control at the file level, at the storage level, encryption, security. So I think that's how an organization can make a decision what route to take. That's great. Did we miss anything? Anything you want to add to our discussion?
No, I think
This is good.
Yeah.
Well, thank you so much for joining this episode.
Thank you.
I really cannot thank you enough for sharing your knowledge and everything you do for the Postgres community. And now, talking about community, we are going to have a second guest join us. Thank you.
Thank you, Sanjay. Thank you. Bye.
All right. So our second guest is my new friend, Melissa Logan. We met a few weeks ago at Data Council Austin.
Yes.
And can you please introduce yourself?
Sure. My name is Melissa Logan. I am a CEO and founder of Constantia.io. We are a tech community company, and we work with a number of different independent communities. We also run our own communities end to end, one called the Data on Kubernetes community that we're going to talk about.
So what are the different communities that you run?
Another one is Data Mesh Learning Community, which is in fact where you and I met for the first time, which is why I was at Data Council.
Yeah. So a lot of people who watch It Depends videos are also very interested in data mesh too. So you founded a company, and so you manage both these communities. How can one join Data on Kubernetes community?
Well, Data on Kubernetes community is an independent and adjacent community to Kubernetes. So it's very much a public open community. Anyone can join it. We have about 4,000 people on the Slack instance. It's a place for end users to get together to share best practices and resources for how to run data workloads on Kubernetes. So as you and Gabriele have been talking about, it's still a new it's a new approach still for a lot of people. In fact, today we had a panel here at KubeCon where we talked about data on Kubernetes and Kubernetes operators. It was a very packed room, and we asked how many people were running workloads today and how many weren't, and about half, maybe about 40% said they were. So there's still a lot of people who are brand new to running data workloads on Kubernetes. So that's why we were created to give people a place to do that. And we provide a number of different programs and resources to help people connect with each other and learn as they go on their DOK journey.
That is great. How many members do you have?
There are over 4,000 people on Slack now.
Oh, wow.
And then we've got, and we're funded by different sponsors too. So we have about 20 or so different sponsors that help, fund the work that we're doing.
I see. And who are these sponsors?
We have DataStax as a platinum sponsor, Google and Percona are gold sponsors, and then we have 20 or so different silver sponsors. We also have a new community collaborator program that we started this year. It's for any open source project that is foundation backed. So they're not going to have a budget to be a sponsor. We don't ask them for any kind of monetary exchange, but it's an opportunity for people in the DOK ecosystem to join and collaborate with people in our community. So there, I think as you heard, data on Kubernetes, it's not just one thing. There's Kubernetes, but to run data, there's databases, there's AI/ML, there's streaming workloads, there's all kinds of different workloads, analytics workloads, and they all have different types of projects and technologies that they use with Kubernetes. So for example, Rook is one of the community collaborators we have, and we are talking to the folks at Apache Spark because we hear how can people use Apache Spark with Kubernetes well. We want to have conversations about that and bring them into the community to have those conversations.
That's great. Very exciting. Thank you so much for sharing this. This is happening in real time, right? And you're building the community. So thank you for joining this episode. Really glad you stayed till the very end, and wishing you all the best on your Kubernetes journey. Until next time, thank you. See you. Bye.